వైరాన్ బిట్టే అలాగే ఆయనకి వెళ్ళలేదు కదా, నా దాని నుంచే వెళ్ళింది. సంకర్య తాగడానికి దొరుకుతారు మీకు. ఈవిడ
మాట్లాడింది నవ్వుకుంటా సార్ నేను టీవీ నైన్ లో 9:30కి ఆ టైంలో తింటాను ఈవిడ వస్తుంది చెప్తారు సార్ అందులో మాట్లాడుతుంటే అప్పుడు బాగా మాట్లాడేది తీసుకోండి కొడతా ఉంటాయి ఇప్పుడే నిన్నే తలుచుకున్నాను డబ్బాలి ఉంటారు ఎవరు తలుచుకున్నాను నేను తెలుసుకున్నాను కాదు సంగతి
చెప్తా
రాత్రి ఎందుకు ఫోన్ చేయగలను నాకు ఫోన్ చేసి చెప్తాను ఆయనకి చేయొద్దలేదు నేను ఆయనకి చేయమన్నాను వాళ్ళు చేయమన్నాను మరి సార్ అని చెప్తారు అంటే సార్ మార్నింగ్ చేసాం పడుకున్నానని చెప్పి నువ్వు మామూలుగా నార్మల్ లెక్క చేసావు అన్నమాట అంటే మెసేజ్ చూసావు ఇప్పుడు రిప్లై చేయాలి నేను ఎగ్జామ్ కాన్ఫరెన్స్ లో బాగా రాసావా నేను ఎగ్జామ్ కాన్ఫరెన్స్ లో బాగా రాసావా నాకు కాన్ఫరెన్స్ మాట్లాడుతున్నాను నాకు ఆన్సర్స్ కావాలి చెప్పారు కదా తెలిసిపోతుంది అంతా అన్నాం. బాగానే ఉన్నారు అందరూ అంతా. రాత్రి బాగా తెలుగు మాట్లాడుతున్నా తెలిసి మాట్లాడుతుంది.
అది పొట్టిది, నువ్వు పొడుగోడు.
చేసుకొని అన్నావు కదా. నీకంటే ఒక మాట తక్కువ. ఆచార్యులు ఫోటో పెడతా చూసుకుంటాం. పెద్ద
నీ మొహానికి సర్టిఫికెట్ ఎవడో ఎక్కువ, మళ్ళీ ఎక్స్ట్రాలు ఒకటే పొట్టిదా అంటే
ఏంటి ఎందులో పెట్టాను? హోల్డ్ లో పెట్టానా? సార్ ఎక్కడ ఉన్నారు? కాన్ఫరెన్స్ లో ఉన్నారు అనుకున్నారా ఏంటి? పక్కన ఉన్నారు.
పక్కన ఆడుకోపా.
నువ్వు కాదా వచ్చాను నీకు ఎలా నీకు అన్ని తప్ప ఎవరు గుర్తురారు.
బా యాదవ్ బిస్కెట్. గుర్తొచ్చాడు ఫోన్ చేశా. మరి
చెల్లి చెల్లి అని చెప్పి గొడవ పెట్టుకుంటారా?
చెప్పు దానికి ఎందుకు మర్చిపోతాం.
ఇన్స్టాగ్రామ్ లో అందరికీ ఈయన చూస్తావా? ఈయన చూస్తావా నువ్వు? అందులో తెలియదు అక్కర్లేదు. సూర్య అంటే తిన్నారా లేదా అంటే ఎంత నాకు అడగలేదు కానీ అన్ని తిన్నారా లేదా సరే కానీ స్పీకర్ ఆఫ్ లోనే ఉంటుంది కానీ ఈ స్టాటస్ లో కేఏకి అంటే ఏంటి సంపు దాపగా చెప్పాడు సంపు దాపగా చెప్పాడు అతిగా మాట్లాడాలని ఏమన్నావు
అతిగానే మాట్లాడాడు అతిగా మాట్లాడాలి అతిగా మాట్లాడాలి
అవునా
ఏ పిల్ల తిండి ఎలా తినాలి తిండి ఎలా తినాలి
ఎక్కువ వెంటనా నేను ఫస్ట్ అసలు అమ్మాయి ఫోటో తీసి అబ్బాయి ఫోటో వస్తున్నాయి ఇంకా నేను అడిగా నేను తెలుసా మీకు అని అంటే ఆ తెలుసు మా అక్క వాళ్ళ ఫ్రెండ్ కదా నేను దేవుడికి వచ్చేది
అదే ఇది ఎవరిని వదలడంటరా రత్న ఎవరిని వదలడా ఏం పులియారా బాబు నీకమ్మా జీవితం చీరాలంతా సంఖ్యనాగిపోతుందంట పాప వంశీగాడు వీళ్ళు ఎలా వచ్చారో కానీ వీడికి దృష్టిలోకి
జాతి క్రీస్తు ఎగ్జామ్ ఆన్సర్స్ అప్పుడు కనపడతాను. మనం మార్క్ టెస్ట్ కూడా కాన్ఫరెన్స్ లోనే రాసాం. ఇక్కడ డేటా మొత్తం ఉంది. కాన్ఫరెన్స్ మాట్లాడారు, ఏం మాట్లాడారు, కాలేజ్ అంత డేటా ఉంటుంది
సార్. అయిపోయిందిలేండి, వచ్చింది. మీరు వస్తే మేము కనెక్ట్ అయ్యింది. ఓకే, మీరు వచ్చేస్తే
అండ్ ఫోన్ ఇస్తే పక్కన వేస్తాడు.
మొన్న కూడా అలాగే వెళ్ళింది కదా.
మొన్న ఫోన్ ఇస్తే పక్కనే జరుపుకుంటుంది. ఇస్తే మొన్న ఇంటికి వెళ్ళి ఫోటో తీసుకునే సాయాన్ని ఫోన్ ఇస్తే పక్కన వేసాడు. సరే కాలేజీలోనే ఉన్నాయి, కాలేజీలో ఉన్నా నువ్వు నీ డేటా మొత్తం ఉంది. ఎవరెవరు తీసి రాశారు, ఎవరెవరు ఎక్కడ తీసి రాశారని కాన్ఫిడెన్స్ మాట్లాడేది మాక్ టెస్ట్
బాగా కవర్ చేసింది.
బాగా మాక్ టెస్ట్ టైమింగ్ ఉన్నప్పుడే, మాక్ టెస్ట్ ఇంకా లాస్ట్ 3 minutes ఉండగా మీరు కాల్ మాట్లాడుకుంటూ మొత్తం డేటా ఉంటే Anil coding ada.
Anil sir. Anil sir. Ravi sir.
Good morning, one and all. I am Dr. C.H. Nagasatish Kumar, HOD and Professor, Civil Engineering Department, Bapatla Engineering College. The Civil Engineering Department organizing 3-day webinar on emerging trends and the challenges in construction projects. The topic in association with the BEC alumni team. So the topics in this 3-day webinar course is only practical oriented only, no theoretical and no research type. So what are the different technologies adopted in the construction field and what are the challenges faced in the construction field? The topics is also very interested. In the first day, the tiles installation by Radha Kanth garu, and in the second day, waterproofing solution and solution for concrete structures by Santosh garu. These are the industrial persons only. And in the third day, types of failures in RCC construction by A. Srinivasra garu. So these are the only practical oriented topics only. So regarding our department, the department is the oldest department in this institute. The department was established in the 1981. So the department offered the 2 courses, UG with intake of 180 and PG with intake of 18, MTech Structural Engineering. So this is the brief introduction of our department. Now I request the convener of this 3-day webinar, K. Ravi Kumar, Assistant Professor in Civil Engineering Department. So give a brief introduction to the today's speaker, Radha Kanth. Thank you and very much. Thank you.
Good morning to one and all. Thank you, sir.
Good morning.
Myself, Ravi Kumar. I'm working as an assistant professor in Bapatla Engineering College, and I feel very happy to invite Mr. Radha Krishna garu to deliver a lecture on this 3 days national webinar. And coming to his profile, he has around 30 years of professional experience in successful people management, accomplished through people management, leadership, teamwork, excellent training capabilities, excellent communications and interpersonal skills, technical and industrial skills, problem analysis and solving expertise, sales and management building, client network. Coming to his educational qualification, he has done his bachelor's degree in civil engineering specialization from Osmania University, and he did his master's in marketing management from IGNOS. Coming to the professional experience, presently he is working as a national level manager, technical services, head technical services and a training division of MYK Laticrete India Pvt Limited. And coming to his committees and memberships, he is a life member of Indian Concrete Institute, committee member in a Bureau of Indian Standards for developing of new codes for India, authored revisions of IS 15477 2019, working group member of in International Standards Organization ISO TC 189 for development of codes. I would like to invite Radhakant garu to take over the session.
Thank you so much, Ravi. Thanks for the introduction. Explain you what are all those opportunities that are available and how uh, how we all can fit into this field. So today topic is emerging trends and technology in tile and stone installations. Now you would have heard about cement, you would have heard about concrete, etc., etc. so far. So now we will talk about the finishes, the tile and stone. This is an industry by itself. So coming to our organization, we are called MYK Laticrete. MYK Laticrete. MYK stand for the initials of our company's directors, Mr. Muralidhar Yadama, the photograph that you can see on the screen. His name is Muralidhar Yadama. He is a ceramic engineer and entrepreneur, a young man, and he started this company about 20 years back. In the year 2000, he started this company, and the vision is to deliver innovative solutions and new eco-friendly products. That's the vision of the company. And as we go, you can see, when we started off, it was a small office with 5 people in 2000, 5 lakhs per month business, and we were importing the products from US. Our principal company is called Laticrete, which is based out of US, and this was started by a chemical engineer called Rothberg, Henry M. Rothberg. He is the man who started this particular division of construction chemicals, and that was called as US Rubber Company those days. He introduced this word called thin set adhesive, meaning the tile and stone that was installed traditionally, they were using big blobs of cement, big chunks of cement and sand mortars to install the tiles and stones. So he replaced the whole concept by introducing a very thin bed adhesive. That is why it is called as thin set adhesive or thin bed adhesive. And we formed a joint venture in India in 2000, as I said earlier, and started with a small office. Today we have 4 factories and 1 factory coming up in Sri Lanka. We serve the entire country, 23 branches across, and we also serve SAARC countries from Hyderabad. Our corporate office is in Hyderabad, and we have a fantastic R&D facility in Hyderabad where we do all kinds of testing, all different varieties of codes. We do the testing, all the products we do the testing, and we are a group of companies. As you have seen our managing director, Mr. Muralidhar Yadama, we have several companies under the umbrella of MYK group. So we have one company called Turbovent, one company which manufactures cement, which is Parashakti Cement. We have Arment. Arment is a construction chemicals company from Germany, and we formed a joint venture initially called as Schaumburg, and then now we completely own MYK Arment as a construction chemicals company. And we also have a spinning company. It is called as MYK Spinning, which is non-engineering company. That's the only non-engineering company under the group. And we also have interests in software and CAD, computer-aided designing and making the designs for clients in US and all that. So we have a big, perspective when it comes to engineering. And as we go to the topic today, we will talk about the emerging trends. What are those emerging trends as far as the tile and stone installations are concerned? Now, apart from whatever that you are seeing on the screen, like I'm sure all of you know what is a substrate. Substrate is a place where you install a tile or stone. Substrates are changing, tiles are changing, stones are of multiple kinds. All these we will talk as we go to today. But before that, it is also important for us to understand our limitations. What are the challenges and limitations today in the industry? Number one is the, as far as the workforce is concerned, today there are not many skilled people available in the country. With this corona pandemic today, again, all those skilled labor have gone to their respective places, and it becomes very difficult for us to bring them back. That is okay, it's a temporary issue. But then we have other major issues. Second major issue is availability of sand. Sand is not easily available. Mining is very, very difficult today. So that is another issue. And the quality of sand is also very poor. Then third that we have is the cement. Now, cement has changed over a period of time. The technology of cement has changed, meaning they have started grinding the cement finer and finer. When we were students, we talked about 33 grade and 43 grade. 43 grade was coming new in the market. And that itself was a big achievement. Oh, so we have 43 grade cement. But what exactly has happened to cement is that the particle size of the cement has become thinner, smaller and smaller. So if you take 3 similar cups and fill them up with 33 grade, 43 grade and 53 grade cement, you will find large number of particles, very high number of particles in the 53 grade cement compared to 33 and 43 grade cements. That's because the particle sizes, the grinding technology improved and the particle sizes has reduced. Now, in a particular volume, when you have a large number of cement particles, there are large number of reactions that are happening with the water, because it reacts with water. And so there is huge amount of heat that is being generated. So thousands of joules of heat is generated, which ultimately is, what is it doing? It basically is affecting the water that you give to the matrix, cement and water, whether it is a concrete or a plaster or a screed material, whatever that you are making, it affects that matrix. Because of that heat, the water gets evaporated. When the water gets evaporated, there is no sufficient water for this chemistry to move forward. So it starts cracking unless you supplement it with additional water, what we call as curing of the matrix. Whether it is concrete or screed or a plaster, you have to start curing quickly because of high strength cement that we have, like 53 grade cement today. And that was not the case earlier. How is it relevant for this field? I will tell you. So looking at the challenges today, these are all the challenges. Your cement is high grade, then you have skilled people are not there, and then you have difficulty in getting sand, very good quality of sand. Now, these are all the present challenges in the market. And what are those things that have happened in tile and stone installation for the last 50 years? If you see, all these which are there on the screen have been affected. Now, we will go one by one. Many people are not aware about these changes in the technology. And another thing is, we need to understand, we need to comprehend why there is a problem, why the problems are surfacing, because of advancement in the technology. Now, substrates, if you see, where the tile and stone is installed is a substrate. That's a background on which you want to install the tile and stone. Earlier times, the tile and stone was installed only on concrete or a plaster or a screed. But today, we want all the tiles to be installed on plywood. We want the tiles to be installed on gypsum board. We want them on bison panel boards. We want them on calcium silicate boards, metal, glass, mosaic tiles. So existing mosaic tiles, you want to install another set of tiles over that. Ceramic tile is already there. You want to install a new tile over that. Stone, you want to install a new tile or stone over that. So we have so many new substrates where we want to install tile and stone. And we had been installing tile and stone using cement slurry. Cement and water mixed like buttermilk, and then we had been installing tiles and stones. So the traditional cement sand is not going to work for all these, new substrates, the challenging substrates that you have. Now, say for example, you have a tile that needs to be installed on a metal frame. Now, in this case, this company wanted to install a stone, very interestingly, a stone called onyx. Onyx is a translucent stone. It allows the light to pass through. Now they wanted to install this onyx on the metal frame that you see on the screen. And so only the metal frame needs to be utilized for installation of the stone. So what needs to be done? So obviously your cement sand is not going to work. You require an advanced kind of material. See, this is what we did. We have given them a product with a very, very high tensile bond strength, which will hold on to metal as well as the stone. And this stone, onyx, allows the light to pass through. So it looks very beautiful during the day with the corridor looks lightened. And during the night, they put lights from behind. So it looks very, very attractive during the night from the front. So this is possible. Now, the second challenge that has emerged, and there's a lot of things that have happened. The trend changed is the tile. Earlier, my childhood, the tiles were very small, and they were predominantly clay and maybe ceramics. Ceramics were just coming in that time, and the sizes were very, very small, limited, like 4-inch by 4-inch or 12-inch by 12-inch. But over a period of time, these ceramics have also changed and transformed, and they've become vitrified porcelain tiles. Then there are glass tiles and glass mosaic tiles. Then there are metal tiles, agglomerates. See, today, you have if you are a rich man, you can have gold tiles in your bathroom. You can have platinum tiles in your kitchen. So it all depends on how much money you can spend in order to get a beautiful designer tile. And there is something called agglomerates also. Agglomerates are engineered stones. They are not natural stones, but they're engineered stones. So the tiles sizes have increased over a period of time. They've become larger and larger. Today you have 10 feet by 5 feet tiles, and the tiles have increased in thickness and then again reduced in thickness, the sizes being bigger. So now we have a large, very large format, thin tiles which are available, made with ceramic material, made with vitrified material. So the body will be vitreous, the body will be ceramic, but the thickness is very, very low. That is a very thin tile and a large format. Now, all these definitely give you a challenge in installation. This is not going to be easy, and you cannot do it with a cement slurry. Now, what is the difference between the old tile and the new tile? If you see, the old tiles, natural clay or ceramic tiles, have a lot of pores behind. You can see it in a photograph, which is magnified many times. And on the right side, you see homogeneous vitrified tile. So you don't have pores on the right side, whereas there are a lot of pores on the left side. Now you can relate when you do a cement mortar for installation of natural clay, then the cement and the water will get into this pore that is available in the natural clay or ceramic tile, because it is highly absorbent, and it forms a mechanical key. So it is holding on. Whereas you come to vitrified tile or a glass mosaic tile or agglomerate, your absorption is very, very low. And there are no pores in the tile. So there is no mechanical key that is happening with these vitrified homogeneous tiles. So what happens is Cement, though it is a beautiful binder, it is beautiful binder. Cement is a binder, all of us know, but it does not establish a good bond with vitrified tile compared to the clay tile because of this difference of porosity. Higher porosity, better is the bonding, better is the mechanical key. Okay, let us discuss as we go forward. Now, if you see stones are a different varieties of stones. Earlier, when we were, in the college, we had very limited stones like Betam Cherla, Kadapa, Dholpur, Shabad, like that. But today, you take one granite. There are different varieties of granite. There are 50 varieties of granite. There are 100 varieties of granite. You take marble. You will get some 30, 40 varieties of marble. And many stones we make, they are available in India. We sell and we also export, and we also import a lot of stone. I'll tell you something which is very interesting. The onyx stone that we talked about in the frame, where we have just installed it on a frame, the translucent stone which allows the light to pass through. You know where it comes from? It comes from Pakistan. Pakistan has a huge chunk of onyx stone available in their country, and that's where it is imported from. So what happens is all these natural stones which they come from Mother Earth, they are naturally available to us. So what do? We extract them as boulders, then we cut them into layers, and then we process them, we polish them, and we bring them to the site in different sizes and shapes. But remember, these stones come from the Mother Earth, and they have absorption. They're basically absorbent in nature. So when they absorb, what happens? Whatever, while installation of the stone, they absorb the cement slurry, and so there is a change in the color of the stone. While using the surface after installation of the stone, something falls over the stone. Say somebody is eating rasam sambar and it is falling on Italian marble. There is this turmeric in this and tamarind also in this sambar, and it gets absorbed into the stone because of the porosity. And what happens? The water eventually evaporates, but the stain remains on the stone. That is the problem. So this needs to be addressed while installation. Post installation, you have to have technology products. You cannot go with a slurry system because it is going to spoil the installation and post installation scenario. So applications. Now, another important thing that has happened over a period of time is the applications have changed. Earlier, tiles and stones were mostly restricted to only bedrooms and bathrooms, kitchens probably. But today, it is easier if I ask one question, where you, instead of asking where you use a tile or stone, it is easier, it can be easier answered if I say where you don't use a tile or a stone. So almost everywhere we use tile and stone today. And there are a lot of applications that you can see: commercial, residential, kitchen, etc. And then some of these installations are highly demanding, basically because the place where they are being installed, number one. Number two, the sizes, the large formats. And number three is the kind of processing that they go through, what is the basic material that they possess of. Is it vitrified or a ceramic or a natural stone or a agglomerate? So it depends on what is it made of. Now, for example, we did this project in 2003 to now is about 17 years. The entire building is cladded with red agar stone. Red agar stone is a heavy stone. It is also highly absorbent. So we had to take, as engineers, we had to look at a few aspects. Is my substrate strong enough? So we had to make the plaster strong first, because it has to hold on to the stone, the heavy stone. It has to take the load. It has to transfer the load to your block work, and then eventually block work will transfer the loads to the structure, so the frame. So we had to work from those all the angles of the capability of your plaster. So improve the capability of the plaster, then give a good adhesive, because now this is external surface and this is exposed to all kinds of weather conditions. This is in Hyderabad, by the way. So there is a huge temperature difference between summer and winter. And so there is expansion contraction that is happening. So we had to take care of lots of aspects. So I will speak about it as we go further. Another interesting thing that you see, this is our R&D reception area. You see Italian marble in the ceiling. You have Italian marble on the floor and you have Italian marble in the ceiling. No. Now, all of us engineers, we know that we have a very good solid substrate there. There is a roof which is made of concrete. But remember, this roof or this concrete ceiling, can it really hold on to a granite? Can it hold on to a Italian marble? If you ask this question, you will be surprised. Even if you have a 50 grade or 45 grade concrete roof there, it is very weak in tension. So when you are trying to pull something, when you are trying to install a heavy material onto the concrete, this area, the cover concrete, will be weak and it will not hold on to the heavy material like granite or Italian marble. So what we do is we have a framework with wires which will go and hold on in the steel in the concrete, and then so we make a framework with metal and then install the Italian marble using the same technique which I have shown you on the frame, for the onyx. So we use the same technique and install it. The adhesive that we give for this installation has a very, very high tensile bond strength, which is like 120 kg per centimeter square area, M2R. So it's huge capability. It's one of the best adhesives in the world. You don't have adhesives which can hold better loads, and it also has a very high shear bond strength. Now, another aspect that has changed over a period of time is the construction practices which have changed. Earlier, when my father built the house, he took 1.5 years to construct 4 rooms and a kitchen. And 1.5 years, literally, everything was done by the book, using the book. And that was not a framed structure too. It was a load-bearing structure that time. And today, in 1.5 years, we deliver a 20-floored building to the clients. All of us are under pressure. And because of this pressure, we also compromise on a few things. So when we are compromising, when we know that we are compromising, say, for example, I'm not able to do the curing properly. For a concrete, I have to do 21 days curing. For a plaster, I have to do 7 to 11 days. For a screed, I have to do 7 to 11 days. All these curing practices, it cannot be done, by the book, because all of us are under tremendous pressure to deliver. The quicker, the better. So what happens? Even the clients, say, for example, you're all civil engineers. I'm also a civil engineer. But when I am going for purchase of a property or a flat from a builder, so what do? I go back to him and tell him, boss, I require this delivery on so-and-so date because the Pandit has fixed the housewarming ceremony date. And it is as per my horoscope, it has to be done like this. So there are so many things that we come up with, and we put tremendous pressure on the builder. And the builder tries to, accommodate everybody and then tries to finish the job as quickly as possible, in which there will be issues because we are using technology products. And so we need to be careful. We need to come up with ideas to counter the effects the problems that surface because of the speed of working. Now, architectural designs are changing. Earlier, the architects were, belong to different schools of thought, and then they used to design like that. But today, architects are also fighting with each other. They want to have the best designs done. So they give us the challenges. Now, particularly when it comes to the finishes, say for example, a train. They were making this holiday train called Deccan Odyssey. It flies between Maharashtra and Rajasthan. What it typically does is it travels during the night. Daytime, it stops at a station. People go out for a local sightseeing. Now, this train is an expensive train. It's a holiday train. So interior looks like this. It's good for couples, and then attached with a wash area. Now, if you see the wash area, there are vitrified tiles installed on a framework in the train. Now, this framework is made with a plywood surface. Now, this plywood surface was 6 mm. Now, the challenge, all of you can understand that a train, when it runs, there are vibrations, there are shocks, and there are thermal variations in this, because all this is AC train. During the night, AC is full on. During the daytime, AC is switched off because people have gone out for a sightseeing. So what happens here is there are heavy thermal variations, there are vibrations, there are shocks, and all this, the assembly had to take the assembly of plywood and the tile. So we proposed a couple of products which were tested by the R&D of railways for 99 years of performance. 99 years of performance under simulated conditions. Those are same conditions that they created, just like what happens on the train, and then finalized the product. So this is how it is done. Now, if you're looking at all these emerging trends, we as a company, MYK Laticrete, have the solutions to see that these installations, the tile and stone installations, are durable. They become durable. And we've been running this for the last 60+ years internationally, and in India for the last 20 years. So we have various products. I'm not speaking about the products today. It is whatever that I'm saying today is only a touch base. Like, I just want you to understand that there is a huge scope for civil engineers in this area. Now, before I go further, I would like to give you a brief on the traditional methodology of working and what is happening in India. In India today, if you take the tiles, only tile market, there is about 90 crore square meters of tile that is sold annually across the country. 90 crore square meters, just imagine. And almost equal area of stone is also sold in this country, like 85 to 90 crore square meters of natural stone and all kinds of stone is sold in India. People buy so much of tile and stone in this country, almost 180 crore square meters. Now, out of this 180 crore square meters of tile and stone, which is being sold in this country, just imagine only about 8 to 9% of that total value, total area is being installed using an adhesive, using a technology product. Remaining 92-93% of all the tile and stone that is being sold in this country is installed using cement slab. Just imagine. That means if you come into this industry, you have work for the next 50 to 100 years. Why? I'll tell you. When we started this company in India, way back in 2000, the amount of tile and stone that was installed using adhesive was 2%. Today, it is 9%. Now, the difference between 9 and 2% is 7%. So in a matter of 20 years, the adhesive adoption has increased by only 7%. So if we go in this pace, you can imagine what happens to cover the entire 92%. Let us not worry about all the 92%. Let us look at next 20%, 25% with adhesive. Now, having understood that there is so much of potential in this field, you can see what is the difference between the traditional system and MYK Laticrete solutions. Let us look at it. For example, there is a floor. Now, floor, when you want to do tile or a stone installation on floor, what do? You get cement, you get sand. That too, sand is of inferior quality. Whatever that good sand is already used for concreting, for your plaster, your screed. So whatever chota mota is available, that you are bringing it and putting it on the floor. This is where we start. This is the floor where it is ready for screeding and tiling. But what do? Do we do the screeding? We don't do screeding. We dump all the cement, all the sand here, and then we try to, if everything is good, we put some cement on this, and we run so much. Remember, if you go back and see, the offset is 3 to 4 inches. Do we really require 3 to 4 inches offset? But we have our own, reservations. One, the levels are not good, so I need material to cover this to come to finished floor level. Number two, I want to run so many things under the screed, like this, total wiring, some pipelines, and everything runs under the floor. And then what is that we come to? We come to this. There is a concrete deck, floor deck. Now it is ready. So what do? We bring in sand, we put the sand. And remember, there is bulking in sand. Sand also bulks. When you put water, it bulks. If you put excess water, it settles down. If you put less water, it is of no use. Now what happens here is you have a sand here, and then you are broadcasting cement slurry. You mix the cement with water, and just you're broadcasting, you're on the surface of the sand. Now all this is exposed. When you are doing the tiling, all this is exposed to different environmental conditions. Some of the water is being taken by the floor bed. Some of the water is going off into the environment. If it is summer, like the one that we've had, some of the water is going off. And under those conditions, we are bringing in the tiles, like vitrified tiles, for example, and installing them without any gap between the tiles. We don't put any gap between the tiles. What is that we are doing? We are not allowing the tiles to adjust or move in any way. So, and under these circumstances, if you just turn the tiles and see, here this is what you see when you see a vitrified tile installed using a traditional technique. Now, internationally, there are certain standards. Even in India now, we have made the standards that at least 80% should be the adherence between the substrate and the tile. When you install a tile or stone, it has to be minimum 80% adhesion. 80% contact area should be there. That is for general areas. If it is a critical area, like external facade, for example, or a bathroom, or a kitchen, or a wet area like a swimming pool, it has to be 95%. So, that it has to be there. But you can see what happens when you do a traditional tiling. The contact is not even 50%. And that is where all the problems come. If there is excess water, the whole of the bed will shrink, and the tiles will start showing the lippage. This is called lippage. One tile will be below, another tile will be above. That is called lippage of tiles. So there is a difference. And if there is less water, there is it is not enough for hydration of cement, and so the reaction is not completing, and so it is cracking. Now, any which way, these is going to produce something called a hollow sound. Now, if you see, this is from a real site. One of the builders, he said, "Sir, please, can you do something?" Now, if you observe very closely, the substrate, the sand is like, very loose. It is not cured properly, and the quality is also pretty bad. So what happens here? And there is no space for the tiles to move. So what happened? All the tiles cracked. And this fortunately happened before the people who came for occupying the place. So these are the issues. And then what happens? You can see, many of us, this is the hollow sound, and it is you can observe this. There is no space between the tiles. How do we do it? We actually take a white cement, and just put it as a paste over that. And many of the tile companies also say, you have jointless tiles. Jointless tiles doesn't mean that there are no joints between the tiles. The edges are cut very well. That is what they want to convey. But here, these tiles allow water to freely go through, and there is absolutely no space. And this no space will not allow the tile to adhere to the substrate properly. And so you have listened to that. Now, one of our clients has sent this video. You can see this. This is one video from Maharashtra. One of the clients has sent, "Sir, what should we do?" So it is so loose, and I don't see much of cement there, and so the whole thing failed. No spacer used. So all these will lead to problems. So it is important for us to understand the requirements. It's very, very important for us to understand the requirements when you are actually working on the tile installation. Now let us look at wall tile installation. Usually what do? We create a plaster. On the plaster, we create the key marks. This is why key marks? Because we want the next cement to hold on to the key marks. Excellent. We have a good idea. We want to have established the mechanical key with the cement and the old cement. We want to establish our cement mortar with this plastered area. We want a key. But what about the tile? Tile is a vitrified tile, so it doesn't establish a mechanical key. But what do? We put the tile there, and then we just try to hold it one tile over the other, and finally put a white cement paste, tika. You can see the key marks on the left side wall, and on the opposite you can see the tiles without any spacers. And what happens? This is what happens when there is a pressure that is exerted on the tiles. One tile exerts the pressure on the other tile. The weakest point will start chipping off. So that is what happened in this picture. You can see the chipping of the tiles happen, and subsequently, once the stresses are built over a period of time because of these movements, because we know all the structural elements, all elements in a structure move, they expand and contract. And we also use them left, right, center in our own way. We have hot water running, cold water running, so there are thermal variations. There will be expansion because of hot water, and contraction because of cold water. All that we know, but we ignore the fact that we need to allow the tiles to move. And so this is what is happening. And so you see the entrance. At the entrance, you see the tile cracked. On the wall of the bathroom, you see there is a lot of water which is locked, because now the water can go through even if there is no joint, because there is a joint, but it is not filled with any material. There is no space. There is enough space for the water to get in. So water gets in and stays in that gap between the wall and the tile, and eventually shows up in the adjoining bedroom or hall. And this basically builds up lot of fungus, because the water stays in the wall for a long time. There will be fungal growth, and that fungus is going to affect the people in the house. And people think that, okay, I am living in a AC room, so nothing is going to come to me. But this AC will keep rotating the fungus within the room, and so those people who are living in such rooms, they fall sick frequently. So this is what happens. So this is how the tiles, crack over a period of time. And this is, you can see the cement mortar shrinks. The traditional cement mortar always shrinks, and so the tile is fallen off. You can see. So what is that we do? What we do is how to address this. Now, when you know that you have used a cement, a traditional cement, any cementitious material, whether it is concrete, plaster, screed, any cement, when you use, you know that you have to provide water for it to cure and become strong. And in the situations where we do the tile and get out, we don't have time to look back and do the curing, and that's where all the problems come up surface, and there is no spacer between the tiles. So what is that we have done? The first thing that we have done is, how do I address this? If there is a problem of I'm not able to cure the basic substrate, the bed that I am giving, the leveling bed. So what we have done is we have introduced a cement which is engineered in such a way that first day, whatever water that you give, that it holds on and cures itself. It doesn't lose its water from the matrix. So that is the cement. It is called as an engineered cement. It is called as Laticrete 100. I don't want to talk about the product, but that is the concept. So where it holds on to the water, and now it is best always if you do a screed, a leveling bed, a plaster, let it cure, let it attain its strength before installing tile and stone. So it is the best method to have a cured surface and then have a adhesive applied over the cured surface to install a tile and stone. So this is what happens. And under the same circumstances, under the same environmental conditions and thermal variations, now the water is contained inside the matrix, and it is not allowed to go out either to the substrate or into the environment, and hence it takes care of its own curing, and the whole of the bed becomes very strong. And you can adopt the same the traditional methodology, what we call in the industry as wet on wet. So traditional method is just put a slurry and put the tile. That's a wet on wet system. This is a wet on dry system, meaning when you want to install a tile using an adhesive, you make a leveling bed, you make a plaster, you make your substrate ready, let it become strong, and then you go and do the tiling using a advanced technology material like an adhesive. That's the best method, where it ensures the durability of the entire installation. And we always prefer to have a spacer provided between the tiles and subsequently filled up using the right material depending upon where the tiling is being done. Is it interior tiling, exterior tiling, wet area tiling, or a dry area tiling? Is it on the wall? Is it on the floor? So we ask these basic questions. Where are you doing? See, it is like a marriage between a boy and a girl. So you would like to, you should first understand the characteristics of the boy. So what is that material that is available for tiling, and you should also understand the characteristics of the girl. And then, having understood both, how do I bring them together and make sure that this marriage lasts for a longest and durable, marriage. So that is the intent with which you should work when it comes to installation of tile and stone. And remember, most people are so highly focused on the structure, on building the structure, but when it comes to finishes, they lose that focus, and they think that they're not part of the structure, but it is part of the structure, and you need to treat every element in the structure as part of the structure and how it behaves with the other materials. So this is exactly what we do. We analyze where are we installing. See, look at this. Now the installation is so good. It is 100% adhering. The tile is 100% adhering with the substrate. When you use an adhesive and tooled with something called a notch trowel, which I'll just show you as we go. So there is an advantage when you go shift to adhesive technology, because now the adhesive also, whatever the adhesive that is available that we supply, it doesn't require curing, and so there is absolutely no problem, no shrinkage, and it is reinforced with polymer. So its binding power is very, very high. If you look at cement binding power, it is only about 0.5 MPa or 5 kg per centimeter square. Our basic adhesive always starts at 12 kg per centimeter square, and it can go up to 120 kg per centimeter square area. So greater bonding strength, uniform coverage, and consistency is what is required for a long-term durability, the marriage to last forever as part of the structure. Because as we want the structure to stay for a very long time, we want these finishes also to stay performing for the entire period of the structure. So this is how the installation is done using the adhesive, and you can see these are the tools, and there are different varieties of adhesives that are available. This is the basic difference between a traditional system and the thin set system. Thin set is always lightweight and output is faster, quicker. There is more flexibility, no debonding, and better bond strengths, no cracks. Grout joints, in fact, add to the aesthetics. Many of the architects don't agree with us, but by providing the grout joints, you are allowing the tiles to move, number one, and number two, their performance becomes better, and the looks also look better because now the sizes are increasing. Now we'll talk briefly about grouting. Grouting is a general word in civil engineering, and you listen to this word grouting in many areas. Some people talk about pressure grouting in the concrete. When there are honeycombs in the concrete, you inject you put an injection and then do a pressure grouting. And there is grouting material available for the machine based plates. When you are constructing factories, you have to install a machine, you have a base plate, and you actually use a pourable non-shrink free flow grout. That's a different grout. Now for us, the grout is the space filling material between two tiles. When you provide a space between two tiles, we call it, with a spacer, it's a spacer joint, and in that joint the material that you fill in is called a grout, a tile grout or a stone grout or whatever. So why the joints? Why should we provide joints? All these reasons are given. Tiles are not dimensionally stable because even the tiles are manufactured in a factory, and you don't get exact, measured tile, batch to batch, tile to tile. There will be variations. So you need to live with all these variations, and you need to accommodate them while you are doing the installation. And the narrow joints always gather dust and very difficult to clean. Once it is dusty, it's like a permanent feature. And most of the tiles in India are maintained using acid-based cleaners. All these acid-based cleaners only spoil the, once they go through the joint, the paper joint or a butt joint, when there is no spacer, it is called as a flush joint or a butt joint or a paper joint. So but liquids go through. And you know, cement and cement based materials like your plaster, your concrete, your screed are highly alkaline. Now when there is some acid which is going and meeting this alkaline material, what happens? There is a neutralizing process that is going to happen. When the cement based material neutralizes over a period of time because of constant exposure to acid, then if it is losing alkalinity, there is no strength. Its strength is also lost. So that is how structures start dilapidating. So this is one area where the acid water goes, because in India, all the tiles are washed on a daily basis using acidic materials, acidic cleaners. So this is why we say don't allow the liquids to go through freely. So, you know, provide spacer. See, this is what happens. You can see in the traditional methodology, white cement is pasted, tika. So we always recommend to use a spacer and fill it up. If it is a bathroom, go with a epoxy grout, because it can take the acidic attack. In bathrooms, you use acids, you use detergents, you use a lot of soaps and shampoos, etc. So it should not spoil the substrate under the tile, and subsequently should not lead to a waterproof issue. So this is what is done. This is a very popular product, SP100. You would have heard about it, but then I'm just you know, telling you, this is epoxy grout, can be done even on the regular areas, halls, commercial floors, etc. So this is how it looks. And we have a product for exterior surfaces. This is a polyurethane product, and UV stable. Normally epoxies are not stable, so we don't recommend them for exteriors. So for interiors, for exteriors, we have this Stella SP100 or stain proof 100% epoxy is used only for interior areas, and many colors are available. So architect is also happy. He can choose a matching color or a contrasting color, and he can go. I'm just giving you one case of facades. I'm not talking about the entire range of applications because now I have about 15-20 minutes time. So I'll talk about facades. Facades, why I've chosen this is that all the facades are exposed to environmental conditions. They are exposed to summer, you know, heat, and they're exposed to rains, they're exposed to winter chills. So depending upon where the facade is, external wall application, the temperature variation is so high that there is a lot of expansion and contraction, expansion during summer and contraction during winter. And the traditional method had been good for all the thick stones, like 40 mm thick stones, 35, 40, 50 mm thick stones. They were all fine. This is how they used to do. They used to put S-clams and, you know, anchors and all that. But when it comes to vitrified tile, there is no way to make holes or grooves in the vitrified tile. So there, nobody was thinking about installing a vitrified tile or a digital tile on the external surface. That's where the advanced technology adhesive comes into picture. There is an advantage. So all the problems with the facades of installation with traditional system, you know, resulted basically because as civil engineers we need to understand that there should be joints, movement joints, control joints. Of course, the expansion joints are part of the structure. We design the expansion joint. You can see this. This is an expansion joint. You can see this is part of the structure. So this is, all these joints are also very important. And when we design a system for tile and stone installation, we look at all these aspects: the expansion joints, the movement joints, the peripheral joints, the control joints. All these are also part of our engineering, and they are also applicable for the finishes. Otherwise, you can see all the problems. This is one of the premier institutions in India, and they had to barricade the entire external area. They had a beautiful, actually, walking track. They have barricaded basically because of the stones falling. It becomes very, very dangerous. So these are all the issues, and tiles were never even thought about for installation of facade on facades. So finally, we have the products, the systems. As I said earlier, for Tata Consultancy Services building, we look at first strengthening the substrate. The plaster is strengthened or the concrete is strengthened, and then we give the adhesive, which is good enough to transfer the load of the stone or tile into the substrate and subsequently to the structure. So we have the complete systems for this, and whether it's interior or exterior, we have different varieties of adhesives. It is not just one adhesive, we have different varieties of adhesives. So we ask a few questions like what is the size of the tile or stone, and where are you getting it from, what is the material it is made of, and whether it is suitable for the existing structure or the plaster that is already there or a concrete that is already there, whether it can take. And what is the substrate? Substrate, is it a concrete, is it a plaster, is it a drywall board like a plywood or a cement baker board? So we ask this. We need substrate, we need what is the type of the tile, chemistry of the tile, and what is the size of the tile, and where you want to install, whether you want to install on floor or wall, interior, exterior, wet area or dry area. So we ask all these questions before we actually jump in to give the total installation system. So this is Tanzanian Embassy in Delhi, East Coast Railways headquarters. This is another condylite, is a very heavy stone, and they have done beautiful sculpture work on all these, these brown patches that you see. These are all beautifully sculpted. A lot of sculpture work that is done. Because of the shot from a long distance, you cannot see that. But this is a large format stone, and many. Now look at this. This is interestingly Walt Disney World. Looks like a painted building, but it is not painted. They're all tiles. This is in US, and the tiles are installed on the surface of the building, so it looks so beautiful. So architecturally also, design aspect also can be done very well, using adhesives, because now you have the flexibility to use the adhesive and install any type of tile or stone. In fact, in Saudi Arabia, we give adhesives for installation of gold mosaics on the tombs of the mosques in Saudi. So we have. Now, can anybody tell me what is this facade made of? Now, anybody who looks at this is our R&D building, and on the top floor is my training center, where we have classroom, and then we have area for working with the products, a demonstration area. So this facade looks, when people are going on the road, it is right on the highway, Bombay highway. So when people traveling, they look at this facade and think that it is ACP, aluminum composite panel facade. But actually, if you see all these white, these are all vitrified tiles, 2 feet by 2 feet vitrified tiles with a large joint of 10 to 12 mm, filled with cementitious grout material. And we did this about 10 years back. 2009, we did this building. And in this building, we have used all the products that we have had. And you can see, I've already shown you the Italian marble in the ceiling. This is the facade that we made with vitrified tiles. They're self-cleaning. There is no problem. One rain, they'll all become sparkling clean. And it's very easy to maintain too. And then we have natural stones. If you remember, natural stones are absorbent in nature, and they absorb. And so what happens is, while installation and post installation, you need to take care of them, because anything once goes inside, it becomes very difficult to remove. Your tamarind goes inside, turmeric goes inside. It becomes very difficult to remove that, because the stain remains as a stain. So so it's important to understand that we protect the stones. So we have something called a sealer, which seals the stones off. And there are two major sealers. One is called a top coating sealer, The other is called impregnating sealer. Now, what is the difference? Top coating is basically a layer of material which is applied on the surface of the stone, and this layer will not allow any penetration to happen. Now, so what happens is there is no possibility of moisture escaping from the top coating. Whereas when you have an impregnating sealer is a nanoparticle which goes inside the stone pores and settles there, and it lowers the surface tension of the stone and does not allow the higher surface tension material to enter into the stone. So higher surface tension material like water or oil is not allowed to get into the stone, and hence they remain only on the top surface and can be removed with the your mopping or maintenance cleaners. And so impregnating technology also allows the vapor to pass through without any problems. We also have one finishing material called Lata finish, which is a putty, cement based putty, apart from tile and stone installations, because people are asking us, why are you not in finishes? If you say you're a finishes installation people, you should have white cement based putty also. So we have white cement based putty, a fine putty, coarse putty, and then we also have certain primers for that. And we have plasters too, cement based plasters which don't require curing, which can be applied using a machine, spray applied machine. We just apply, but manual finishing needs to be done, and just forget about it, no curing required. So this is the difference between conventional putty and putty. Before I close, I just wanted you to understand the scope of this area of finishes. So that's how this is only a touch base. We can have a second level session in future because your college is very, very interested. It's an old college. They want to really take it forward. So this is a case study of Alhambra. Alhambra Tower is in Kuwait. You can also check it in National Geographic, YouTube. You can just type Alhambra and you get about 6-7 videos. I think third or fourth video has this installation where they have installed limestone on this structure. This is, look at this structure. It is almost half a kilometer in height, about 417 meters high, and it has 30,000 square meters of facade. Now, all this concrete facade that you see, this is all concrete facade. It is aerodynamically, it turns, and it is designed in such a way. But remember, such large and tall structures, they have issues like there is a sway in the structure because it is very tall, and when there is a sway in the structure, one phase compresses, the other phase is in tension, and this side when it goes, this side is in compression and this side is in tension. And so whatever adhesive that you are giving for installation on the surface should have great flexibility, should have enough space to move. That means the spacers must be there, and it should also have a great shear strength so that it doesn't fail. So they have formed a committee, a technical committee, and they studied various adhesives, and finally they've chosen one product from Laticrete called Laticrete 254 Platinum, and this is what they have used, and this is the structure when they were making it. And you can see this is the limestone that is being installed. You can also see it in the video. I think third or fourth video. You just type in Alhambra, then you see how they have installed this limestone using a cementitious adhesive. And another example of the capability of an adhesive, it is not a very good example. Many people told me it is not a very good example, but it is an example. You can see why today everybody is concerned. This is a supermarket called Bullock's in US. Way back in 70s, there was an earthquake, and the whole of the structure came down. You can see it had tiles on the surface, entire surface. So the whole structure came down. You can see the tile is still intact. So when you design a system for installation of tile on in an area, whether it is interior, exterior, uh, you have to fundamentally look at the engineering aspects, understand the substrate properties, understand the tile properties, understand the conditions where this tile is being installed, and then subsequently during the course of its service, what is the exposure that it is going to have. So all this you need to understand. So here the adhesives that we look at, always we talk about shear bond strength and high flexibility, and should have water resistance, and then thermal resistance for thermal variation. Of course, fire resistance, always, it comes as an inbuilt quality. So these are all the qualities that we look at: the shear, the thermal variation, and moisture exposure, freeze thaw conditions. Deflection should be accommodated in order to go ahead with a tile that is going to stay for a very, very long period of time. That means we are ensuring the marriage to be the best marriage. And so all the products are eco-friendly. Today we talk about the green products, green technology. We need the products with low VOC, and the very reason why we have several factories across the country is to see that the carbon footprint doesn't go up. Your project site to the factory distance is very, very minimal. As per the IGBC norms, again, it should be below 800 kilometers, within the 800 kilometers radius. So we have factories. We have done many major projects across, not only across the globe, but in India too, we have done many. And many of the major builders and architectural firms are associated with us, and we are very, very thankful for all of them to stay with us, because we understand the technology, and whatever that we design is based on the engineering practices, civil engineering practices, and so that there are no problems as we go into the future. So this is how we are different from the others. We always look at what is required. We design based on the substrate properties, finishing materials, and behavior, installation areas, environmental effects, maintenance conditions, and long-term effects. And that's where we come in. And remember, there's a huge scope for engineers, civil engineers, and there's a long way to go. This industry is very, very small today. It's only, as I said earlier, 9% of the total tile and stone installation, which is like 180 crore square meters. And we are talking about, say, 15, 16 crore square meters of tile and stone using this kind of technology. It's a long, long way to go. And so I hope this has given you a basic idea as to what we are. And floor and walls, we have the R&D facility. In fact, our R&D serves entire world. All Laticrete companies across the globe, we give the service from our R&D in Hyderabad, and 60 years plus experience. Any tile, any stone, anywhere is what we say. Yeah, low VOC products, value for money. Thank you so much for this opportunity. Very soon we will have the next level of presentation as to what will be the critical requirements as far as the civil engineering aspects are concerned, and how to go ahead and design the tile and stone installations, finishes. So this is only a touch base, and thank you so much for giving us this opportunity. I would like to thank the head of the department and for giving us this opportunity today. Thank you so much. Yeah.
Yes, sir. Sir, there will be a question and answer session, sir.
Sure.
The very first question is, what are Bison deck supporters and where do I use them?
Pardon, sir. What are?
What are Bison deck supporters and
Bison.
where do?
Okay. Bison.
And
Bison.
yes, sir.
By,
Bison.
Bison panel, Bison decks or Bison panels are made with a composite material. Composite material is made with cement and wood particles. So they are used in place of plywood today. Say for example, you want to make doors like this. They make with Bison panels. Say for example, you have these doors, these kind of doors. So these doors are made with Bison panels. So here, today's industry, the Bison panel has become a substrate where they want to install tiles. How do they do it? They just design a dry wall between a bedroom and a bathroom, and that dry wall will serve as a substrate for the tile in the bathroom. Outside, it will be looking like a simple ply sheet with a design element on that. So that will be there in the bedroom. So it's basically a dry construction. It is used for dry construction. That's the whole idea of Bison panels. Yeah.
And another question is, sir.
Yeah.
Manufacturing process of tiles.
Yeah.
What is the manufacturing process of the tile?
Okay. Now, basically, we are not into manufacturing tiles. We don't manufacture tiles. We bring the tile and the substrate together to install. But I will, anyways, I will tell you the manufacturing process. Tile is basically manufactured from clay. A clay that is available. Place like Kakinada, there is one RAK factory, tile factory. You can also look at the YouTube, and the clay is mixed with the materials, with the pigments and the design element and then it goes through a kiln, hot kiln, for a certain amount of time. Usually, if it is a ceramic tile, it is about 800 degrees centigrade, the exposure of heat. And if it is a vitrified tile, it is about 1200 degrees centigrade plus. And it is, they go through this kiln for a very long period of time, and they cook. The whole process is cooking process. So it is like baking. So they bake and get cooked, when they go through these heat chambers, and finally the tile comes out. Once the tile comes out, there is a layer which will be given on the surface of the tile. Engobe it is called as, and then finally a glazing layer will be given on the top surface of the tile. So that final glazing layer is today, again, digital technology is being used. So it goes through a chamber where there is a digital printer which will broadcast the inks. So suppose somebody wants, if I want my face to be on the tile, so that I can feed it into the system as a design, and that can print digitally on the surface of the tile. So it is basically the printing technology, digital printing technology, but the basic tile is cooked with the earth, the clay that is taken from the earth. And there are other materials which are mixed into it to take that heat, absorb the heat, and still be there without cracking. Yeah.
Hello, sir.
And
Yes, sir.
Hello, sir.
Yes, sir. Yes, sir. Listening.
Sir, I have a practical problem.
Yeah.
Especially in a headroom of staircase. We have provided 4 air vents at the top, and they were filled with glasses.
Okay.
Glass panels.
Okay.
With an adhesive of silica gel.
Okay.
But ultimately it has not served the purpose of not leaking the water.
Okay.
But the water in the first rain itself, the water has leaked through.
I see.
What shall I do, sir, for that?
Yeah. See, basically, the adhesive, silicon based adhesive is also a good adhesive, no doubt about it. Looks like the guy who had done the job did not do a good job, because even for me in my house I have a dome, polycarbonate dome I have, and that polycarbonate dome is fixed using a silicon based adhesive only. It is also watertight. So I don't blame the adhesive. Probably if your substrate, which other substrate do you have on the edge of the glass?
Only concrete.
Okay. Okay. Then if the silicon has a high flexibility, so you require a material which has a high flexibility. So we have a polyurethane adhesive which is called as PUA 212. Polyurethane adhesive, which is highly flexible and which can adhere both your metal, glass, concrete, glass, etc. But it will be in white in color. It will not be translucent or transparent like silicon. You will be able to see the white this thing, because it is a glass. You will be able to see. So I don't have any transparent or translucent adhesive. But this PUA can be used without any problems. It's a beautiful material. It also does not allow the water to go through if it is done properly.
Is it available in the market, sir?
Yeah, it is available. Yes, PUA 212. It is called Laticrete PUA 212.
PUA 212. Okay, sir. Thank you.
Polyurethane adhesive 212. Yeah.
Okay. Thank you.
Thank you, sir. Yeah. Any other questions?
Another question is, sir. Yeah, yes, sir. How much time it will take for the engineered cement to attain enough strength?
Okay, good question. See, this is also cement. Please note. And whatever time that a normal cement takes, this also takes the same time. There is no change in the cement. Only engineering that we have done is to hold on to the water so that it cures by itself. It doesn't require additional, external supply of water. That's how we have designed it. So otherwise, in all its properties, your setting time, everything is same like cement only. And it has a better binding capability because it has some additional polymers in them, and so it makes the cement more easy to work with, and also higher in bond strength when you're using it as a screed or a plaster, and it improves the flexibility too. Yeah.
And one more question is that, sir.
Yes.
Is there any effect of climate or climatic changes on the adhesive, which is we are using for bonding of tiles, that is laticrete?
Okay. Now, it depends, as I said earlier, it depends on where the tiling is being done. Say, for example, if it is an external facade, you have all the environmental effects. First being the temperature rise and temperature reduction, which is thermal variation, what we call as thermal variation. Because of thermal variation, there are expansions and contractions both in the substrate as well as the tiles. But there are two different materials. Your substrate, maybe it is a plaster or concrete. Your tile is, say, vitrified tile, for example. So what happens? The coefficient of expansion for vitrified tile is different from coefficient of expansion of your concrete or a plaster. So there are two differential expansion coefficients with which they are working. So when there is a change in temperature, it goes higher, there is an expansion that is happening, but differential expansion that happens in tile and the substrate. Similarly, when the contraction happens, there is a differential contraction. So because of this, there is a stress that is generated between the substrate and the tile because of expansion and contraction. this will lead to, if it is a cement, say for example, a traditional cement, it is rigid in nature. Cement is rigid in nature. So if you have a plaster or a screed or a concrete, it is rigid. It does not allow this expansion and contraction to happen. So the differential expansion and contraction between the substrate and the tile or stone is resulting in failure of the bond, because the material, the binder, does not have the enough flexibility. So that is the basic thing that is going to happen. We have different situations depending upon different installations that we have. Say for example, swimming pool. Swimming pool is a totally different conditions, set of conditions. Facades have different set of conditions. Floors have different set of conditions. So there are various varieties of loads which are coming in, and those loads need to be accommodated and taken into the structure. And then the expansions and contractions which are happening, and based on the format of the tile, the larger the format, the more flexibility is required in your adhesive. So that is how the adhesive is designed. So when we have a set of adhesives, we have 15, 16 different varieties of adhesives. Each has its set of capabilities. So we decide which adhesive goes into the installation depending upon all these conditions, not just the substrate and the tile, the size and the environmental conditions. So all these need to be done. That is how it's important for us to actually do the assessment of the installation, asking all these basic questions. I think I have answered your question.
Yes, sir. Okay,
Yeah.
thank you, sir. I feel it's time to conclude. And
Yeah.
initially, I would like to say thank you very much, sir, for
Yeah,
accepting my request.
I should thank you so much.
And it's a great presentation, sir. And uh, because of your presentation, we had a great insight into the tiles. As of now, most of people are aware of the traditional way of tiling. And with your presentation, we get a good exposed to the latest technologies in the tiles
Yes.
installation. And one more thing I would like to say is basically a fresh graduate will feel that if we want to continue a career that will be in the industry, like in the construction or planning or QS, like that. But
Yes.
with your presentation now, I feel few of the students maybe known that they have a career in this aspect also. So I feel it will be a great opportunity for the students who enter into this field.
Yes.
And once again, I would like to thank you very much, sir, for
Thank you
your
so
great
much.
presentation.
Thank you so much for this
Thank
opportunity. I would like to thank the entire management and the head of the department, and those people who have worked behind, had been coordinating with me. Thank you so much.
Thank you, sir. Thank you.
Have a great
Thank you,
time.
Anand.
Stay safe
Yeah,
and take care of yourself.
thank you, and wish you the same, sir.
Thank you.